Looking at exponential decay, we want to compare growth and decay. When the factor is bigger than 1, that's going to have an increase in population. It's going to be an increase or growth. Multiplying by 1 keeps 100% of what you have. 50 times 1 is going to stay 50. And then if you do 50 times 1.1, it's going to be even bigger than 50 was. So it's going to have growth or increase in population. Whereas if your factor for A is between 0 and 1, it would never be a negative number. But if it's between 0 and 1, you're going to have less every time. If you multiply by 0.9 instead of 1, you're only going to get 90% of what you had. You're going to have a 10% decay. If you multiply by 0.8, that's going to model a 20% decay. 0.7 is a 30% decay. 0.6 is going to give you a 40% decay, and so on. So the population is going to decrease. If it's a number between 0 and 1, that's going to model exponential decay. So you can tell right by looking at the value of A whether it's growing or decaying. Other than that, this stays the same as growth. C is still the initial amount. It's the y-intercept, but also we can have A be a decay factor. We've talked about growth factors, but we can also have decay factors. So looking at these models, we want to figure out, is it growth, which I'm just going to write G for, or is it decay, or we'll call it D. Looking at each piece, this first one, M of T, 15 is the initial amount, and then A is 0.45. So A falls in this category. It's something between 0 and 1. This is modeling decay. If it's a number between 0 and 1, it's decay. If it's bigger than 1, it's growth. Looking at the next one, the initial amount is 26.4. And then A is 1.62. So that 1 is going to keep 100% of 26.4, your initial amount, and then it's going to be 0.62 more than that. So this is going to model growth. Anything bigger than 1 is growth. Anything less than 1 is decay. The next one, the initial amount is 5, and the growth or decay factor is 1/2. Well, 1/2 is 0.5, so we would call that a decay factor. It's between 0 and 1, so it must be decay. And looking at this last one, there's something different about it. The initial amount is 12, but looking at that one compared to the other functions above, it was a number times a growth or decay factor raised to the t. So we had our initial amount times a growth or decay raised to the t. This one's not. This one's raised to a negative t. So we can flip this, right? If you change the location, you get to change the sign. So I'm going to write it as 3 over 2 and raise it to a positive t. If you move the location, you get to make it positive for the exponent. And now that we see it like that, we want to figure out, is 3 divided by 2 less than 1 but bigger than 0, so that we can call it decay, or is it bigger than 1, so we should call it growth? And 3/2 is 1.5, so this must be growth.